This is problem number 10 from section 2.4. In this problem it says find the following limit using limit as theta approaches 0 of sine theta over theta equal 1. And they give you the limit as x approaches 0 of tan 2x over sine 3x. Now because we have sine theta over theta, our first thought should be, can I take tan 2x and convert it into some sort of sine function? Well, we know that tan theta is equal to sine theta over cosine theta. So I can replace tan 2x with sine 2x and cosine 2x. And by the way, before I start, I should have said that when I plug in the 0 in for x, sine of 3 times 0 is sine of 0, and sine of 0 is 0, and we can't divide by 0, so that's why we have to do these manipulations. So this would be equal to limit as x approaches 0. I'm going to replace tan 2x with sine 2x over cosine 2x. And that's over sine of 3x. I'm going to write that then, obviously you flip and multiply this, you can write that as a limit of x approaching 0. This is sine 2x over cosine 2x times the reciprocal of this, which is 1 over sine of 3x. Now I want to point something out here. When I plug in 0 for cosine, I get cosine of 2 times 0, which is cosine of 0. Cosine of 0 is 1. So because cosine 2x is in the denominator and it gives you 1 when you plug in the limit, this cosine 2x is not a problem. It's just the sine that's the problem. So what we're going to do is we're going to do that same algebra manipulation that you've seen in previous problems. We're going to write this as sine 2x over cosine 2x times sine 3x. And because I want to cancel the signs out essentially using this property sine theta over theta equals 1, I'm going to multiply the top by 2x over 2x so I can manipulate this a little bit, and the bottom by 3x over 3x. If I rearrange this, then I get limit as x approaches 0 of, well, when I multiply that together, that'll give you 2x sine 2x all over 2x. And on the bottom, I'm going to get cosine of 2x times, when we multiply that, that'll be 3x sine 3x all over 3x. Now you can see that this is starting to shape up how we want it to, so we're going to say limit as x approaches 0, and we're going to now take the 2x out front, so we're going to say 2x times sine 2x over 2x, and we're going to say that cosine 2x times 3x times sine 3x over 3x. And you can see that this is like the same as this.
Barnhart to Student Services, please. Brody Barnhart.
So you're going to get a 1 and a 1 here. We get limit as x approaches 0. This will be 2x times 1 over cosine 2x times 3x times 1. The 1's cancel, or they're insignificant, right? And also the x's cancel. So you're left with limit as x approaches 0 of 2 over, when I take the 3 multiplied to the front, I get 3 cosine 2x. Now I can plug in my limiting value, so I get 2 over 3 cosine 2 times 0. So I end up with 2 over 3 cosine of 0, and we know cosine of 0 is 1. So because this is 1, it's just really just 2 over 3 for the limit. So I can say the limit as x approaches 0 of tan 2x over sine 3x, that's just 2/3. So we had to do a little manipulation to get there. Get rid of this, essentially sine 3x in the bottom, and we find our limit is 2/3.